Alright, alright, alright. Love cosines, extra credit proof. Get some extra credit. Thanks for being there learning at home with me. So this is where we came up with the law of cosines. And so as you can see, this is a non-right triangle. This angle looks kind of close to a right angle, but no, it's not. And so they had to develop a way to solve triangles where you only have maybe side angle side, or side side side, or angle angle angle. And so they came up with this amazingness. So then we had to, thanks Mrs. Bradford, yeah. So then they came up with this proof, and using just labeling some different things there. So they called the altitude, they call it h, and then they call this side length x. And then they just call opposite big angle C is little angle c. Across from big angle A is little a. And across from angle B is little b. But this time they wanted to figure out how to use right triangles to solve non-right triangles. So if you draw an altitude straight down, that would create some right triangles, right? And so if we use right triangles, then maybe we could use SOHCAHTOA or Pythagorean theorem to help us solve the missing parts of the non-right triangle. And so starting off, we went ahead and had to find this part right here. So then, if this whole distance is b, so this whole distance right here is side length b, and this distance here was x, well then what would this distance be? And so this distance would be the whole distance b, take away x, and then that's what's left. Whatever's left is what's left. So we just labeled that as b minus x. So then we can use the Pythagorean theorem to help us with these two triangles. So the first triangle has h and b minus x, and then the hypotenuse. Remember across from the 90 degrees is called the hypotenuse. So these two sides are going to be the hypotenuse. Good. Awesome. So then we'll do h squared plus b minus x squared is equal to a squared, right? Cool. Thanks for copying this down. Extra credit for you. So then, let's see. Can we see another right triangle up there? Oh yeah, this one right here, right? Where you have h and x and c. Let's use that one as well. Cool. Okay, so then we'll go ahead and do h squared again. Ooh, h squared twice. That's interesting. So h squared plus x squared is equal to c squared. Now, what if we solve for h and plug it into the other one? What a good idea. So we're going to go ahead and minus x squared over to this side. Nice. And then we've solved for h squared. H squared is equal to c squared minus x squared. So now we're going to take that whole thing, which is equal to h squared, and we're just going to plug it right in place there. Substitution. Again, what's our main goal? Our main goal is to come up with a formula that gives us a, b, and c in it, all the side lengths, in case we ever want to solve for side, 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 or side angle, side, or angle, angle, angle. Cool. So then, but right now we have h's and x's that we need to account for. Make sure this is recording still. Just making sure. Don't want to do it twice. Okay, so then we plug that in there. So in place of x squared, h squared, we're going to plug in our c squared minus x squared. So now we have c squared minus x squared in place of the h squared. So that's this section here. Then we'll just bring this next down. So plus b minus x, good, all squared, good, equals a squared. Nice. Okay, well what else can we do? We got some x's in the way. So how do we get rid of those x's? And then we just have a, b, and c. Okay, well we have an x squared, another x squared. Maybe we multiply that out. Let's see here. So then we have c squared. Well, let's go ahead and solve for x squared. Okay, so now we're going to jump back over here and see if we could just solve for x in terms of cosine or sine. Awesome. Let's see here. So then let's see. What about this triangle? So we have an x here, and we have a c here. Can we use that? Well, this is a right triangle. And so some angle, we're just calling it A. So we could use angle A, cool. And then we could use some SOHCAHTOA process of this one, which let's see. If this is the hypotenuse, and then this over here is opposite, well, we don't want to use h again because we just want to be in terms of a, b's, and c's. But we could use x's and then solve for x. So if that's some hypotenuse and this is opposite, that means this is adjacent. Cool. So then we're going to use adjacent over hypotenuse. Adjacent over hypotenuse. And what is adjacent over hypotenuse? It's cosine. Good job, cosine. So we have adjacent over hypotenuse is cosine. So then, awesome. So then our adjacent is x. And our hypotenuse, we call it little c. Nice. So then, awesome possum, because it's little c across from big angle c. So now if we want to go ahead and just solve for x, we can do some substitution on the other side there. We'll go ahead and multiply c, little c, over to the other side. There we go. Okay, so then we know what x is equal to. Little c times cosine a, right? Little c times cosine a is what x is equal to. So now wherever we see an x, we're going to plug that in. So here's c squared. Is this blowing your mind yet? Blowing our minds. So c squared is equal to, let's make that 2 a little bit smaller, is equal to x squared. Well, what do we know x is? X is little c times cosine of a, all squared, plus, and then we have b minus x all squared, which is going to be b minus, and then x is equal to what again? X is equal to c cosine a. So we're going to do little c times big cosine of angle A. Awesome. There we go. All squared. Here we go. Make sure that we do that and 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 that. Okay. So then equals a squared. Beautiful. Okay. Hey, look at that. We got all a's, b's, and c's and cosines, and that's pretty neat. That's pretty neat. So now we just got to distribute and multiply some of this stuff out, okay? So we get c squared minus, and then this is just going to distribute the 2 there and the 2 there. So that's going to be little c squared times cosine squared of angle A, whatever angle A is. Good. Plus, now this is going to get a little, this is the only crazy part, is how many b minus c cosine a's do we have, right? How many of those do we have? Well, because it's squared, we have 2 of them. So we're going to do another b minus c cosine of angle A. Good. And then, close parenthesis, whoops. Then we have equals a squared. Getting warmer, getting closer to that formula we've been using, or that you're about to use. Okay, so now we're going to write that out. So we have c squared, good, minus c squared cosine squared a, good. And then here goes, plus, so we go b times b is, there's our b squared, good. Then, that's our first times first is first, last times last is last. So then we're going to multiply the last part there, which is negative c cosine a times negative c cosine a. So that's going to be a positive c squared cosine squared a, because we distribute it through, right? So negative c cosine a times negative c cosine a, negative is positive, and then c times c is c squared, cosine times cosine is cosine squared. Cool. Equals a squared. And then don't forget that we do have a b times, so b times the negative c cosine a, and another b times the negative cosine a, right? Because that's your smiley face. There's your eyes, nose, and mouth, and your tongue. And there we go. There's your nose. So don't forget to multiply. No, it looks like another smiley face. Don't do a new vote. Sorry. One more. Okay, there we go. So again, how many of those do we have? We have 2 of them, right? We have a b times negative c, so write that down. So it's going to be a negative b. Good. And then times the c. Good. Cosine of a. Good. So all we did was take that b and we multiplied it with that sucker. But then we're going to do it again, so that means we have 2 of them. So you could just write them and add them together, negative 2 of them. Cool. It gets better. Watch, ready? Now it's going to simplify. So now it's going to simplify. So this positive c squared cosine squared a and this negative c squared cosine squared a are going to cancel. What? Going to cancel with this positive and a negative. So then, cool. So then if we switch a roozy and go ahead and put the a squared equals first, you're going to see something special. So a squared is equal to, you see it yet? You see it yet? You see it yet? Not yet? Okay. So a squared is equal to, wait for it, a squared is equal to, we have a positive b squared on its own, so let's write that first. We're just rearranging, this is associative, just moving things around a little. So a positive b squared, good. Then we also have this positive c squared, so we'll add positive c squared. And then we have our minus 2 times b times c cosine of the opposite of a squared, like the same letter. If this is a, then this is a. Wada bing, bada bang, bada boom. There it is, log cosine's formula. Made it. Good job. Extra credit for you. So go ahead and write this down, and you can email it to me. Take a picture and email it to me if you want to for extra credits, or just bring it in when we come back. And that'll be extra credit for 4th quarter. So that's how we derive the log cosine's formula. Woo! Yeah, thanks for watching. You behind the screen, thanks for watching. Extra credit. Cool. Okay, so thanks for watching. Stay tuned next video. Stay tuned.